In 2015, the United Nations announced a radical plan to change the world. Global leaders drew up a list of what they called Sustainable Development Goals, 17 of them in total, to create a blueprint for a better future. For me, growing up in Afghanistan and now working as a BBC journalist, reporting on stories from around the world, I know how these basic rights are still only a dream for many people. So 5 years on since the UN set its targets, is our world becoming a better place? Today, we are in Rwanda for goal number 6, clean water and sanitation.
In our planning processes, we try to target those that are very far, those that are in the most need, those areas where we have settlements that don't have water. We aim that by 2024, people residing in urban areas get clean water within 200 meters, whereas in the rural areas they get water in 500 meters. That's our aim by 2024.
I'm Sana Safi.
And I am Engineer Dr. Mrs. Sarah Fanny Hackman Duncan, taking the students of the Civil Engineering Department for a hands-on practical section in line with the technical education concept on improving access to water at Accra Technical University.
If you take 120 liters per person in the hostel and maybe 30 liters per person in the academic facilities, we have a total demand of over 100,000 liters per day. And Ghana Water is not able to meet this demand. So always, demand is always higher than what? Supply. As a result of that, we decided to improve the water supply on campus by looking at ground resources. So we brought in people from Water Research Institute to do what is known as geophysical studies to eliminate the areas of high groundwater potential.
This is the pump starter. This one, the pump is down, and that's what you go and see over there on the other side.
So madam, which type of pump are we using?
This one is a submersible pump.
Yes, in order to understand some few things about the quality of the water, after you fetch the water from the borehole or from the source that you want the water to be treated for a certain number of people, you need to bring it to the lab to analyze it, to know the nature and the contaminants that might be present inside. So that is how we have come to the lab.
So we have our borehole sample of water, and then we are supposed to perform experiment on it to determine its hardness. Okay, that is the title against our sample. Then based on the reaction, there will be a color change. Okay, then we will determine the volume of the titan that reacted with our sample.
We have gotten the water quality test report, gotten the pumping test report, and then we are now going to put the pump here and then put the reverse osmosis because the salt content is so high and iron and manganese. So we are putting a plant here called reverse osmosis and then treat the water and then pump it to the reservoir. And then the reservoir will now distribute to the various facilities. So this wall you are looking at is about 65 meters deep. That's where we did the water. And the soil profile I will bring you here so that so every 5 meters we're taking samples. 1 meter. So every 5 we say 1, 2, 3, 4.
The concept of a borehole as a source of water supply to augment and improve water supply to the university's community. The practical lesson included borehole water quantity, quality, analysis, and distribution.
I'm so much excited to see water flowing from the tank, even with 2 outlets, and buckets have been lined up